Bismillahir Rahmanir Rahim. Good morning, class, and this is our 11th episode. We will um, try to make some applications about 5 problems we are going to solve it, and we will try in this segment to deal with this formula, the amount of substance mole, number of moles, equal the mass in grams over the molar mass, which is in gram per mole. We will try to solve some problems on this as an application, and meanwhile we are going to know what does it mean, the amount of substance per mole, how many moles are there, the mass and the molar mass, relative atomic mass, molecular formula mass, and number of particles using value of Avogadro's constant. We are going to deal with this segment, so we already know what is the Avogadro's number, which is 6.02 multiplied by 10 to the power 23. Particles, regardless of what this particle is, atoms or anything else. Let us go and let us see what is going on. Based off one we have learned the last time about the Avogadro's number and also what is meant by the mole, we would like to make some calculations involving the mole. We have this triangle. It is the triangle of the moles equation, which is represented by 3 numbers: the mass in grams, the molar mass, and the number of moles. So the number of moles, or the amount of moles, equal to the mass in grams over the molar mass in gram per mole. And this formula could also be expressed as this, depending on what actually we demand. So the molar mass in gram per mole equal the mass in gram over the numbers of moles. The mass in grams equal number of moles multiplied by the molar mass expressed in gram per mole. So those are the 3 important formulae that we would like to work with, or the 3 important equations, and we are going to deal with them in this episode. Be careful to understand what we want, what is the demand, and also be careful about the protocol we are going to deal with. This is very important. And as you know, each mole of anything equal the Avogadro's constant particles. That means it is 6.02 multiplied by 10 to the power 23. Let us go forward. Now here we are going to make some calculations, as we said before, and the first example, or the first problem, says the following. All these are applications, okay? How many moles are there in 60 grams of sodium hydroxide? So the first step is to determine which substance is under investigation. In our case here, it is sodium hydroxide. So we would like to deal with sodium hydroxide. Now, the second thing, determine the substance molecular formula or formula unit In this case, it is a formula unit that is sodium hydroxide. Now determine its relative formula mass. So the relative formula mass of sodium hydroxide equal 23, which is the relative atomic mass of sodium sodium, and plus 16, which is this sodium is only one atom, so it is 1 multiplied by 23, which is equal to 23, and then one atom of oxygen. The relative atomic mass of oxygen is 16 multiplied by 1, because this is only one atom of oxygen, so it is 16, and one atom of hydrogen, and hydrogen, the relative atomic mass of hydrogen equal 1. When we sum all these together, add those together, it gives us 40. From where I get those numbers? I got those numbers from the periodic table. Sometimes they can give it to you in the problem, but here they are not. So we have to bring them from the periodic table. Now, when I come out with the formula mass, directly when I express this formula mass in grams, I will have the formula mass of the sodium hydroxide. So determine the molar mass of sodium hydroxide equal to the formula mass of sodium hydroxide expressed in gram per mole. So it is here, it is 40. So here is going to be 40 gram per mole. Okay. Now, after that, I'm going to determine the proper equation for that. What is the demand of this problem? The demand is they ask for the molar, how many moles. So I want the number of moles. So what I want is the number of moles equal to the mass in grams per molar mass in gram per mole. Compensate the values correctly. So I have 60 gram, which is the mass of the sodium hydroxide, and I have the molar mass of the sodium hydroxide, which is 40 gram per mole. So I just compensate here, 60 over 40 equal 1.5 gram. So the number is 0.5 moles, 0.5 moles of sodium hydroxide. Be careful that I don't need to write mole, M-O-L-E. I can write it just M-O-L, and this is representing mole. I think it is very easy. It is not difficult. Just go step by step, and you do this protocol as it is. So when you have to, you determine the proper equation of to use, which is the number of moles equal the mass in grams per over the molar mass in gram per moles. Then number 6 is to compensate the values correctly, do not miss. So put the mass as 60 grams and the molar mass as 40, and this will come with the conclusion of 1.5 moles. This is an easy way, 6 steps. Actually, there are 4 steps, because this could be this one could be only 5, and we come to 5 steps protocol as the previous one. Stick on those, because you can add those together. I just write here 6 step in order to be aware that you have to compensate the values correctly. Good. Let us go for the second one. we are going, we will see something different little bit. So be careful about this problem. It is not difficult, but the demand or what they are asked about is different. So problem 2 says, what is the mass of 0.5 mole of hydrated copper the second or copper 2 sulfate? Regardless of what, we just go step by step, the 5-step protocol. And as I told you that number 5 and 6, you can put them in one step. So the first one is like this. Be careful. What is the demand here is the mass. So determine the substances, determine which some substance is under investigation. In this case, it is hydrated copper the second sulfate or copper 2 sulfate. Determine the substance molecular or formula or formula unit. In this case, it is a formula unit, and it is like this. It is CuSO4.52 H2O. This is the formula unit for the hydrated copper the second sulfate or the copper 2 sulfate. Determine its relative formula mass. So I'm going to do this formula mass by very simple math. Is 64 is for copper, 32 for sulfur, because both of them is only one atom. So this is the relative atomic mass for both of them. And then I have 4 oxygen. So it's going to be 16 multiplied by 4 plus 5 hydrogen, and also 5 and 2 10 hydrogen and 5 oxygen. So this is the 5 oxygen, and also this is the 10 hydrogen. Now you can also add this 5 to this 4, so they are going to be 9, and then you multiply them by 16. It is the same. You can do this. There is no problem because it is the same atom. Now determine the molar mass of it. When you add this together, they are going to give you 250, and this 250 actually it is when you express them in gram per mole, it's going to be the molar mass of the hydrated copper the second sulfate. Then you are going to make the determine the proper equation. In this case, it is mass in gram, because what I want is the mass. So the mass in gram multiplied by the number of moles, which is 0.2 mole, and multiplied by the molar mass in grams, which is 250. So it is just, I would like to compensate the values correctly. Mass in gram equal 0.5 multiplied by 250, and this is going to give you 125 grams. Very easy. Just determine, go with the proper protocol, 5 steps protocol, again 6 and 5 and 6. You can marry them in one step, and this is going to be 5 method or protocol, or 5 steps protocol. Here we are going back to ask for a new thing, which is the number of moles this time, but there is a little difference between the first and third examples or problems. Let us see what is going on. Calculate the number of moles in 120 grams of glucose. And this is the formula or molecular formula of the glucose. I said the molecular formula. I didn't say the formula unit because this is an organic substance which has a covalent bonds. Let us go for solution here. The first step is to determine which substance is under investigation. In this case, it is glucose. Determine the substance molecular formula or formula unit. In this case, it is a molecular formula, which is C6H12O6. Determine the relative formula mass. Relative formula mass of them is equal 12 multiplied by 6. 12 is the relative atomic mass of carbon multiplied by 6, the number of carbons. And also 1 is the relative atomic mass of hydrogen multiplied by 12 pieces of hydrogen or atoms of hydrogen. And also the relative atomic mass of oxygen is 16 multiplied by 6. And all, when I do this mass of each one of these and then add it together, they are going to be 180. When they are 180, then determine the molar mass. The molar mass is to do this mass expressed in gram per mole. So it is 180 gram per mole. Now I have the mass, and I have the mass, which is 120 grams, and I have the molar mass, which is 180. And I want to calculate the number of moles. So the number of moles equal the mass in grams over the molar mass in gram per mole. And then by compensation, 120 over 180, which equal to approximately 67.067 mole. Very easy, something very easy. You just go step by step and you just compensate correctly. Do not panic and do not forget to add anything together properly, and then you determine the proper equation that you need to use, and then you compensate the values correctly. That's it. Very easy, and you are going to be the number one in chemical calculations. Let us go. Our fourth problem is a little bit tricky. It is direct, but there is something you have to understand. It says, what is the mass in grams of 6.75 mole of aluminum? And I said aluminum. You can hear it aluminium. Both of them are right. Aluminum is American pronunciation. Aluminium is a British one. So don't hesitate. By aluminum, I mean aluminium, and don't panic. It is the same. Here we would like to use atom instead of molecule, so be careful of this, because aluminium or aluminum or aluminium is an element. It is pure, so it is an atom. So here we are going to use only the relative atomic mass of aluminium or aluminum. Okay, We are going with the same steps. There is no change in our protocol. Determine which substance. It is aluminum. Determine substance's atomic mass, not molecular mass, and in this case it is aluminum. Determine the relative atomic mass at the relative atomic mass of aluminum. Relative atomic mass of aluminum is 26.98. From where I get it? I get it from the periodic table. Determine the molar mass, so I'm going to express this in gram per mole, and that's it. Now, what is required or what is asked about, what is the demand of this, is the mass in grams. So the mass in grams, here I'm going to do that. The mass in grams equal to the number of moles multiplied by the molar mass in gram per mole. Then compensate the values correctly. So the mass in grams of aluminum equal 6.75, which is here the number of moles, multiplied by the atomic mass of aluminum, and this is equal to 182.115. We can make it 182.2 grams. I just put it like this in order you understand what I meant by each one of these. Direct compensation, and there is no problem. 6.75 multiplied by 26.98 equal to 182.115 or 0.101. That's it. You can easily approximate it to the grams. It is easy. I just want you here to be sure that this is only an element, aluminum or aluminium as you say it in British accent. Let us go. Our last problem is also about the number of moles, and we would like also to compensate it very easily. As we said that we have the 5 steps protocol. Remember, in this case I wrote a 6th step, and this 6th step, it doesn't mean anything. You can cancel it and just compensate directly on number 4 and number 5, and that's it. Now in this problem we have how many moles in 85 grams of common salt. Common salt is the sodium chloride. So determine the substance, it is sodium chloride, and determine the substance molecular formula or formula unit. In this case it is formula unit and it is NaCl. And then determine the formula unit mass. You add each one relative atomic mass because it is any of them share with one atom, so it is 80. When you apply them together, add them together, it's going to be 58.5. And when you express 58.5 in grams and mil, you are going to get the molar mass. When you get the molar mass, you just want to go and determine the proper equation, which is the number of moles equal mass in grams over the molar mass, and then you compensate them in number 6. And as we said before, we can cancel this and just say from here we just say equal to 85 over 58.5 equal 1.45 moles. This is an easy way to do it. Just go by one, pause the video for each example and try to solve it yourself without looking to the idea or to the solution. And then after that you see the solution and see the matches, that they match together or not. And If not, if they do not match together, you just have to go another time to do it one by one, and so on. And when you repeat this several times, you are going to be the bro and number one in chemical calculations. Now, by this, we come to our conclusion to conclude this or to finish this episode. And you see how easy, if you follow our 5-step protocol, to finish every problem or any problem in chemistry. So go one by one. Try not skip any of the um, steps of the protocol. Do it correctly, and then by experience, by training, by several exercise, you are going to be number one. Be careful and just put this in mind: exercise makes you perfect. More exercises make you perfect. More exercises make you perfect. I promise when I finished any of the test, I'm going to do the past exams and see how and you can see how we can solve them. Now, thank you for your listening. Thank you for attending this episode. If you have anything, just write me down in the comment section. Thank you and have a good day.